Welcome to Cadence Whiteboard videos. I'm Aneka Sunanda, Director Product Marketing at Cadence. Joining me today is Prashant Teotia, Director Product Engineering at Cadence. Prashant is going to do a deep dive on distributed simulation app and how it works in the chiplet domain. What is a distributed simulation app and what challenges does this app solve?
Yep. So Xcelium Distributed Simulation Verification app is a new technology from Xcelium, from Cadence, which basically caters to the challenges that multi-die designs and their verification bring into picture. So I'll just, in a very simple terms, show that, consider a multi-die design having, say, 4 dies, die 1, 2, 3, and 4. And let's assume that we have integrated all that into a single top. Now, to realize those challenges, you have to imagine that you start with a design and verification of a single die. So naturally, you will have a single design and its test bench, a monolithic one, which obviously you will design and start verifying. And once this monolithic or the single die is verified, naturally then you will go to the next step. However, if you look at from traditional way, and by the way, this is very new field, so it's not like there are a lot of precedences to it, but naturally the challenge that I would like to bring in is from a single die going to the multi-dies from a verification point of view. When a test bench engineer, when a DB engineer has to think of verifying the multi-die, you do not just have to think of test cases and scenarios, you have to first build a test bench. So you have to extend the single die test bench onto a multi-die. So imagine a UVM test bench these days, which is very much prevalent. So for a UVM test bench, you will have n number of BFMs or agents placed at various levels of hierarchies, various interfaces in the design to drive the traffic. That's how you usually typically do your SoC or any verification for that matter. And then you extend that. So if you are having from 1 die to 2, the number of agents, then your UVM test bench, it's increasing by that many X. So it is basically your test bench time. This is one challenge, that you go from single die to multi-die. Then obviously you imagine that you run your test cases. This is your typical dies of certain size, and it takes certain amount of time to complete your test cases and regressions for a particular data route. Now, if you have to go through across the die data routes, then obviously when your design gets integrated into multifold, your size of the database, your time taken for the test cases to run. So basically what I'm talking about is performance. So performance becomes another challenge. And the third thing, that with multi-die, the challenge that comes into picture is the compute. Because today you are having a farm, you're running your regression on an LSF farm on a certain memory, certain performance machines. Now when you are running the multi-die test cases scenarios, then your snapshot size is going to be multiple X of what it is. And hence, you will need high compute, high bandwidth machines. So either maybe your current LSF will have those, but the number of runs that you run on that with multi-die will have to decrease, or you will have to procure new. So the cost, or for that matter, compute infrastructure. So I would rather term it as infrastructure is your another challenge. So these are some typical challenges of how a multi-die design verification engineer faces today. Okay, so from here, I would like to bring on how Xcelium Distributed Simulation app caters to these challenges. Right. So this is a typical very basic diagram, but all I wanted to highlight here was that how simple it is for Xcelium Distributed Simulation app to take care of your multi-die designs by as the name suggests, distributed simulation app, by reducing the amount you take in creating an integrated test bench. Because as we saw in the earlier diagram, your integrated test bench needs additional work with respect to what you already spent for a monolithic design. It is possible, and that's what Xcelium Distributed Simulation app does, for you to put each die as a separate one, where the die 1 and its test bench, which means it is the existing test bench of die 1 and existing test bench of die 2. The tool very easily connects the two dies together via the interface, the communication interface. It could be, as we know, for multi-die designs, a UCIe. In some cases where the heterogeneous ones, a PCIe interface as well, works. Or there could be some custom high-speed interfaces which are enabling the die-to-die communication in your design naturally. Now, since as we know that the start point is obviously a single die for which you already would have a test bench, and if these are heterogeneous dies, assuming, or a homogeneous for that matter. So homogeneous means it is the same design replicated on the other side. So you have single test bench. It's just that it is now being replicated on the other side. Very simply, what you need to provide to Xcelium is the list of all these interface signals which are communicating with each other. So RX, TX, any other IOs of this interface with their corresponding ones in a very simple $distributed simulation APIs that we provide with the tool. And you just simply connect the signals on this side to the corresponding signals of that side, and tool creates a virtual channel, which means you are saving the time of creating the integrated test bench by reusing your existing monolithic test bench, which means your TB time is reduced. The second thing when we talked about was performance, because earlier you were integrated multiple dies together in one snapshot, then running the test case. Here what is happening is that your test cases are running on different in distributed simulation mode, which are integrated by the tool together through these virtual channels, and yet tool gives you the full experience with LRM compliant connections, and so your system simulation works as it is, but in distributed simulation mode. So the performance that we see compared to if you would say integrate the two dies into one and run a test case versus you run that in distributed simulation mode is, from anywhere from 2x to even 5x is what we have seen, with just two dies. And more number of dies you integrate into it, the X factor for performance improvement increases by that naturally, because it is all putting into distributed and putting the weight light. And naturally this means, so this cuts down on the performance implication that we had as the challenge. And naturally when you are using this in distributed simulation mode, the weight on your farm, on your infrastructure naturally gets distributed. Now what you were already having for a single die verification, the requirement you had with your machine, with the farm that it would run on, remains the same. It does not increase with any number of dies you would like to put into multi-die format. So this simply, your infrastructure has no extra load. So your infrastructure challenge, so let me put these as challenges, are met with Xcelium Distributed Simulation app. And as I said, it is very simple, that you have to only provide, an information of your communication interfaces by simple $distribution, $dist APIs calls. And, these can become part of your test bench, compiled together along with your existing test bench, and just the magic for you. So this gives a lot of freedom, a lot of power, and when I say these three aspects, you can have multiple sub aspects to these. But the major part is when you say the TV time, you are not only reducing the effort and time taken to integrate the test bench, but imagine that you have only a single die and you have a homogeneous multi-die design, but the integrated design with interposer and other things come into cycle quite late. However, with distributed simulation app, because you can just define these without really creating any Verilog or any top, without integrating these two together or having a test bench for these, reusing the existing monolithic one, you can actually do a really shift left by starting verifying the multi-die configuration along with single die itself. So it's a big shift left as well, naturally. So this is, in very simple terms. And what we have found is, with the data that we have worked with some big semiconductor companies working on generative AI and automotive SoCs, the multi-die ones, of course, what we have found is that with using the Xcelium distributed simulation app, they have not only found, performance from time, they've also found bugs which are very early in the design cycle, which they would have otherwise found quite, say, multiple weeks later into the cycle. So this is something that I wanted to highlight here.
What about debug? How do you
yes. So debug, of course, remains an important aspect, right? Because you are integrating multiple dies into the picture. And if something goes wrong, then definitely you would want to see where things have gone wrong and how one can easily figure out where the problem is. For example, if you are having a distributed simulation across two dies and something goes wrong in die 2 side, then you should be able to jump from die 2 database into die 1, because you don't know if this is originating from die 1 side or at the D2 side. So with Verisium Debug, as I would call it here, so this is a very well integrated, debug methodology in the tool, where, this gives you multiple features, and these are some things which are very advanced, and these features are being implemented right now while we talk. But for example, when you are having a multi-die configuration, you would ideally like to see that, okay, can I just by debug, can I figure out in my environment, in my multi-die environment, which I have put for the debug using Xcelium distributed simulation app, what all dies are connected and how with each other. So it can give you a snapshot of the overall communication. And then if you want to double click on any corresponding two dies together, you can double click on it and it will give you all the signals that are connected from one to the other. So naturally, if there is any issue with your configuration, any mistake that you would have done inadvertently, you can easily figure that out to this. And because the multiple databases, can be flipped within the single debug GUI, one can even, jump from one database to the other while debugging, as I mentioned here. So there are other aspects as well to Verisium Debug, which is very well integrated with Xcelium, that makes the life of a DB engineer easier to debug when things go wrong. So this is another very beautiful feature, I would say, which is integrated with this technology. I think that's all I had for Xcelium distributed simulation app. Thank you.